Today we're going to talk about arithmetic sequences. So let's start with a pattern first. Find out why it's an arithmetic sequence. So at time 0, we have 1 dot. After 1 minute, we get 4 new ones added. So that's at time 1. Then at time 2, we have the original 4, and then we have 4 more added. And that is time 2. So let's go ahead and make a t-chart. We'll call this M for minutes, and we'll call this D for dots. So at 0 minutes, we have 1 dot. At 1 minute, we have 5 dots. At 2 minutes, we have 9 dots. If we continue this pattern, and the pattern is, okay, we go from here, we added 4, and then we add 4 again. So if we continue this pattern for another minute, we got to add 4. So we're going to add 4. 9 plus 4 is 13. So we add 4. So it looks like we always add 4 each minute. And if we go here, we can see that it's adding 1 minute, because 0 to 1 is 1. And then again, 1 to 2 is plus 1. 2 to 3 is plus 1. So we have a rate of change, which is the rise, divided by the run. And that is equal to 4 divided by 1. And that is known as a constant rate of change. So having a constant rate of change is the first thing that we need for arithmetic sequences. Good. So we have to have a pattern that has a constant rate of change, and that constant rate of change can be positive in this case and or negative. So there's 2 things we know. Now, let's go ahead and graph this. And we're not going to need the negatives, so I'm going to make these mostly positive. So we have 1, 2, 3, 4, 5, 6, 7 minutes. So this is M. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is dots. D for dots. So 1, 2, 3, 4. Here's 5. 1, 2, 3, 4. Here's 5. So we want to graph this, so let's look up at our chart. The first one is 0, 1. So at 0, 1, I started, the D is 0, so the minutes is 0. I start here, and I have to go up to 1 dot. And there's my dot. At 1 minute, I'm at 5. So at 1 minute, I go up to 5. 5. And at 2 minutes, I go up to 9. Okay, so now I can draw a line through those, and I'm going to draw a dotted line because I don't know if this data is continuous or not yet. And let's see, if we go up and look at this, is there any way to get 4 dots if I only put 4 in 1 minute? Well, some people will say you could, and some people say you can't. So I'm just going to leave it dotted for now until we get into a more in-depth context about continuous and discrete data. So let's go ahead and now see what arithmetic sequences are. So arithmetic sequences arithmetic sequences So arithmetic sequences have constant rate of change, their graphs are lines. When we talk about constant rate of change, we're talking about slope. So, and the rate of change can be positive or negative. Now, so let's go ahead and see if we can come up with a recursive formula. Recursive formula. Recursive formula. So we want to know the nth term, and to do that, we need to know the one before it because we're just going to add 4. So a to the n equals a to the n minus 1 plus 4. So recursive formulas for arithmetics are very easy. Explicit are somewhat more difficult because they're of the form a sub n equals d times n minus 1 plus a sub 1. So that means we have to figure out what d is. Well, it turns out that d is the rate of change. So for this one, d is 4. So a sub n equals 4 times n minus 1 plus a sub 1 for this formula was 1. So there's our formula. You can reduce that and do the distributive property, but you do not need to do that. That will be an acceptable answer. So that is arithmetic sequences. So we see a pattern, we make a table, we graph it. The table, we can find that d is a common difference, how it changes each time. If it's a line, then we know it's arithmetic. Recursive formula is a sub n plus a sub n minus 1 plus the change, rate of change. And explicit is a sub n equals d n minus 1 plus a sub 1.